we'll see what happens. All right. I don't know. Maybe if I don't go to class, everything will be better. No, it never works. All right, let's see. So the question, oh shit, hold on. I got Bluetooth mode. Is it connected?
Bluetooth connected.
Oh, thanks. Here we go. So 30, what'd you say, 36, right? Is that the one you're talking about?
Yeah.
Okay. So part of this is this guy here, right? Let me see if I can do some niftiness here. There we go. That's just gonna have to hang out there for right now. Let's see. If I can get rid of that. I don't need that. So let me pull up. Oops, hold on. Somebody's chatting at me. All right, I'll do that in a minute. So let's see. All right, Jeff, where'd you put everything? Here we go. As long as I'm here, I'm going to pull up the laws, but I put some more stuff in chapter 10. Let me pull up the trig laws. Oh, I need to finish making videos of those identities. Because notice it doesn't have anything about cotangent, which is fine. So let me do this. I'm going to pull this guy over here. I don't know what you guys can see now. No idea. Let me stop sharing, start over again. This one. Okay, now. The thing that definitely might freak somebody out is that there's a cotangent of 2x there. And we definitely don't have to memorize it, but we don't even have a definition for cotangent of 2x. But here's tangent of 2x. Tangent of 2x is twice tangent x over 1 minus tangent squared x. So can somebody help me out? What would cotangent of 2x be?
Would it be 1 minus tangent squared of x over 2 tangent of x?
Of course, because cotangent just flips whatever tangent is. I love it. And we talked about this before, and we thought if we played with this, we might be able to write it in terms of cotangent, but who cares? And are you with me so far, Nathaniel? I think it was, I can't remember who was talking to me. Or it might have been private chat, I'm sorry. I might have called you out. No, it wasn't Nathaniel, it was somebody else. I forgot who it was.
You asked? Sorry.
Yeah, who asked?
I did.
I don't know who you are. Sorry,
Oh,
I can't see my name.
Sorry.
Oh, okay. Are you with me so far?
Yeah.
So this you could look up because you don't have to memorize it, but of course you could look up the ones you have to memorize too, because you don't need to know it yet until you have to take something with it on there. What they really have is cotangent, so I just flip this dude, and they have twice cotangent, which will just make this cancel. All right, that's as much as I'm going to do, because now you can replace this with this and then go from there. So
Okay,
part of that is just realizing you've got to look this up. It's not something you have to memorize. It's a double angle formula of cotangent, which is not one of the ones I said you had to memorize. So you have to look that bad boy up. And you start with the green sheet. You go to the green sheet. And if it isn't there, you go back to the section to see if it's there. Does that make sense? Enough sense? I'm going to pretend like that makes sense. Okay. Anybody else? Oh, somebody else had a question. What was it? 42 and 45 in the same section. All right, let me clear this away. 42. Oh, yeah. We talked about this one specifically before. So just to remind everybody, you can look this up. This is the, what do you call, power reducing thingamajig. Let me see if I remember this. I think it's this, right? I'm pretty sure. So then what sine to the fourth would be this thing squared. Are you with me so far? Is that all right so far?
Yeah, I did that. I just didn't know what to do after.
Oh, okay. Oh yeah. So now I got two people asking for number 45. We'll look at that in a minute. So now what I did last time, let's see if you're cool with this. I could just pull this 2 squared out and then focus on doing this. You see that? Because this thing squared is this thing. I really want you guys to see this because it's not very advanced algebra, but it's algebra you're not used to kind of doing. Do you see how there's a 1/4 I could just pull out? And then I can just do, oh, I forgot my 2's. And then I can just do that, focus on this. Are you with me? Are you with me? Is anybody with me? Am I gone? Have I left?
But then wouldn't you still get a cosine to the power of 2?
Totally. And you also have this still, right? So right now I'm just working on this guy. So yeah, you will. And there's a cosine squared formula, which is 1 plus cosine 2x over 2. So that can go here. This is the other piece, and you will get a cosine squared, and so you'll have to use this formula again. So it's a multi-tiered thing.
But you don't need to multiply them, right? Because I know they'll be next to each other like
Oh, I see what you mean. Yeah, this is a nifty one. I like number 42. Because you'll have 1 plus cosine 2x. Let me pull the 1/2 out there. Times 1/4 of this business. So yeah, you have to work on this, and then you're going to have to multiply this out. Oh, that's such an awesome problem, and you guys hate me, but too bad. It's I don't know
Just
how
don't do this to us on the quiz.
Well, listen. This is not a hard problem, and you can hate me for saying that as much as you want to. It really is a stamina problem. Can you just get through this? Can you just do the work that it needs you to do? Let's see. All right, let me stop for a minute. All right, is anybody not with what I've done so far? So this piece is here, right? So there's that piece. This piece is here. So what I have left to do is to multiply this out and distribute it with this eventually. That's so yummy. And then there's a 1/8 out front, right? It isn't, does anyone agree with me that it isn't difficult? You just have to keep going. You just have to multiply it out, get stuff together. The 1/8 can just hang out there. That's why I like to pull that fraction shit aside, because I'm going to have a lot of writing to do, and I don't want to write fractions and fractions and fractions. Let me just pull that outside and forget about it. Maybe. It's okay to disagree with me. Just let me know. Maybe. No?
I get it. It's a lot, but I get it.
It's a lot. That's what it is. And it isn't, well, it really isn't that much either. But it's more than you're used to having to deal with. I understand. Okay. Let me think. There's another question on 45. And for 45, let me see. How do I do this easily? Here we go. Let me clear all this. Yeah, so it's got a couple of things. Reduce the equations to powers of 1 and then check the answer graphically. For the tangent reduction, you're going to have to go back here because I didn't put that on the sheet. But here's the tangent reduction formula. And I know it's a fourth power. So what you're going to do is what we just did, right? We're going to, so fourth power would be this thing squared. So it's this thing squared. Yeah, boy. All right. So you're just going to have to do that. So you have got to identify what is like conceptually difficult, right? There are definitely problems we've had that are conceptually difficult. Like they don't take long to write, they take long to think about. This one is a problem that takes long to write. Does not take long to think about. Yes, go ahead.
I did that, and then I got to the point where there was still a cosine squared x, and then I broke that up, but I don't know what to do after that.
Oh, then you're pretty close to done, it sounds like.
But it didn't match the answer key.
Say again?
But it didn't match the answer key.
Oh, so again, sort of like that question somebody asked me on this problem. If there's a cosine and then multiply by something that has another cosine, that's going to be another cosine squared once you multiply that out. Does that make sense? I don't know if that's what happens. And sometimes the problems, the solutions in the answer key are written in a slightly different way than what you might write them as. So do your best with it, turn it in, and then I can look at it and see if I agree with your answer or if I think the answer key is right. Because sometimes the answers are not the greatest choice, right? That's in the solutions manual. I don't know if you guys can accept that at this point, but at this point you should have seen that sometimes the answers in the solution are not only might have typos, sometimes they're wrong, and sometimes they're not the best choice, or there's other choices of how to write them. Is that all right? So when you do a problem and you look it up in the solutions and you see yours doesn't match and you don't see why and you can't see how to make it match, and then you put a little note on it saying, this is what I got, what did I do wrong? And then I can say, well, the answer key was wrong here, or I can say you did this wrong, right? I mean, that's the worst that can happen. So hopefully you understand what I'm trying to say. I mean, the whole point of this is to do as much as you can on your own, make whatever mistakes you make, and then when you get feedback, see what you did that was right and see what you did that was wrong. I mean, I basically just summarized how math classes work, but a lot of students don't quite get what I just said. The purpose is not to get the exact right answer the first time you try something. So plus the solution manual might be wrong. Okay, that's enough. I'm going to stop beating that dead horse. Anybody else? Let me see. Any other questions, guys? You guys are good otherwise?
Are you making a practice quiz for chapter 9?
Yeah, I was just thinking about that. I've done so many. I know I haven't finished making the solution video for that identity sheet, but I think once I do that, I think that's enough. Yeah, I think that might be enough. Yeah. That along with homework, I think, is plenty. All right. I don't know if anybody's looked at those videos yet. If anybody realized I haven't finished it yet. But if nobody wants to look at those, then I really don't see a reason to make a practice quiz. Okay. Anything else, guys? If everybody would rather have a practice quiz, then I'll just give up on making the solutions to that one thing and try to create a little practice quiz instead. Who wants that? I'll compromise with you. You guys are like, I have no idea, Jeff. So if you'd rather have a practice quiz than me finish up the solutions for that identity sheet, please indicate yes somehow. I have a feeling this mimics how the voting went in some area of the country. I don't know. All right, I'm not getting shit, so no practice quiz. I got one yes, okay. And I got one person said, 2 people said yes. And everybody else is not here, so it's too bad. I'm pretending like they're here, so okay. I love you guys. You got to work with me. Let's see. Okay, solution videos help a lot. That's what I thought, especially if you watch them. All right. We'll see. I don't know. If somebody shoots me an email and says, hey, man, can you do a practice quiz or finish that thing out? And then we'll see what I do. Okay. Nothing else from homework? All right. What I want to do then, if there is
I had a question. Sorry,
No, you're fine. You're fine. That's why I talk slowly as I transition. Go ahead.
That's okay. I sent you a chat. I don't know if you got it or not. Number 33.
Oh, I'm sorry. I see it. Yeah, I looked it right over. All right. So there's 33.92. All right. Let's take a look here. Oh, yeah. This looks very familiar. We did this problem, didn't we? Or we looked at this problem, didn't we? Am I crazy? Well, the answers to both of those questions could be yes. I understand. Oh, wait. You guys are like, what problem? Let me show you. This problem here. This problem. All right, let go. Stop it. Stop it. That looks very familiar to me. This is the problem you're talking about, right? Emily?
Yep, that's the one.
Yeah, we talked about this one. Look at 33. So it says use a graph to see if they're the same. If they're the same, show that they are. Show why, right? So how do you use a graph? You plug this into Y1, you plug this into Y2, and if they're the same, then they will just overlap each other as they graph. All right. This one comes out to be the same. So somehow F equals G. Which term in F or G is the odd one out? Which term in F or G? There's one term.
There's sine.
Sine of 4x.
Totally. So do some shit with this guy. So how can I rewrite the inside so it matches the other angles present?
You can make it sine of x plus 3x, or sine of 3x plus x.
Or either way, yeah, exactly. And then you can use the sum formula for sine, and then you're basically there. Trust me. So I told you a long time ago that one thing to look for with identities is, do the angles match? Right? If the angles all match, then you don't worry about some double angle or sum or half angle or anything like that. But if there is an angle that doesn't match, attack it, right? That's an obvious place to go to. Yeah. So that's the general rule to look for.
Okay, I think I was just confused as to whether they wanted me to graph it by hand or with the
Oh shit,
and
no.
so I was like,
Holy crap.
I was
Oh,
so like confused. I was like, we didn't know, we didn't learn how to do this.
One of these would have been enough in that case, but yeah, this is, they should have put, I think they just put graphing, and they should have put technology.
Yeah, I was really like, we didn't learn how to graph those. That would be really interesting.
You totally could. You can make a XY table, and but no, you don't have to. Don't freak out.
Okay, thank you.
I'm not thinking, let me put that on the next quiz, and I'll give them 8 hours to do. No, I'm not going to know. No. Okay. All right. So if there's nothing else, what I want to focus on, let me show you something, and then I'll talk about what I'm going to focus on today. I have put up here on Canvas, wherever Canvas has gotten to now. Oh, crap. I got so much shit up here. Let me see. Where are you, Canvas? There you are, little dude. Come over here. There you go. All right. So if you go to Canvas, go to modules and come down here to unit 10, I have put blank polar graphs. So if you just Google search polar graph, you could find something. This is one of the better ones I found. I really like this. You could actually buy polar graph paper. You could search Google and get different polar graph images. If you were here yesterday, then we did talk about this like for about 2 minutes, maybe. But why I'm trying to tell you this is you need to print some of these out for yourself, or otherwise get polar graph paper so you're better able to follow along with what we're going to be doing once we start graphing polar equations. We're going to make our own butt graphs and leaf graphs and stuff. Yeah. Yeah. Okay. So I'm just trying to get you ready. So get to the point where you can print some of this stuff out. If you don't have a printer, figure something out. All right. So what I want to focus on tonight, considering not everybody's going to be able to do this tonight, I want to focus on the algebra behind the connection between polar graphics and rectangular coordinate system, right? So that I'm going to do up here. Oh, let me highlight myself because it's all about me. All right, there we go. Whoop. Get over there. Okay, looks about good. For a second, I thought I had it turned backwards, and then I just realized it's just my really bad handwriting. Okay. All right. So if you weren't here last time, what we discussed was instead of using an XY plane to locate a point, let me do this. Instead of using an XY plane to locate a point, we could actually use circle kind of. I almost did it. Let me just cheat a little bit. There we go. It doesn't matter, Jeff. You're not actually going to, I could, instead of using the coordinates X, Y, which means left and right motion, up and down motion, I could instead use angle. How far do I turn? And then how far out do I walk? So to get to a point, I can either tell somebody how much to walk left and right and how much to walk up and down, or I can tell them what angle to turn through and then how far to walk. Let me stop for a minute. Because that's all the XY plane accomplishes, is finding points. There's multiple. Oh my God, guys. This is like your first little baby step into alternate coordinate systems. How many do I know? 7 basic ones. And then you can just go insane with some specific ones for very specific situations. So for example, there's some called spherical coordinate system. That's a 3D version of this. There's the cylindrical coordinate system, right? Anyway. So I wish I would have made this a better graph because I was thinking this wasn't going to be the main thing, but now I want it to be. So let me make that a little bit better. All right, so we've got this point, X, Y. Let me do this better. I'll just call this X, Y here. And I have this alternate method of finding it, which is turn through an angle and walk a certain distance. Okay. Now, can somebody help me out with, if I'm given X and Y, so if I'm given a point X, Y, how can I convert that into a point R theta? So how can I go from rectangular to polar? So this is not as insane as you might think. We know how to do this. We've already been talking about this. How do I figure out this angle given X and Y? For example, let's start with the angle. If I'm given X and Y, how do I, go ahead.
You can use inverse tangent, can't you?
Yes, totally. So I know that tangent of theta would be Y over X. So theta is the inverse tangent of Y over X. Kick ass. So if somebody gives me a XY point, I can convert it to a polar point by using this to figure out theta. And of course, here's the easy one. How do you get R?
Is it
Somebody else tell me.
Pythagorean theorem?
Yes. So then the other thing is, let me write it up here. So tangent theta equals Y over X, and R squared equals X squared plus Y squared. That's the way it's normally written, but Jason brings up the good point. You took an inverse tangent, and here, of course, you're going to square root. So let's do a specific concrete example. What if I'm given the point, let's do one over here, 3, 4. So then the angle, so I want to make the point R theta out of this. So the tangent of theta would equal what?
4/3.
4/3. I love it. So theta, now in your calculator, do the inverse tangent of 4/3. I feel like I should know that one. Is that 57 degrees or is that 43 degrees?
Wait,
That's good. Do you want it in degrees or radians?
Oh, either way.
I got 53.13.
Good. So 53.13 degrees, otherwise known as point. Nobody wants. There it is. Yeah, 927 rad.
0.927.
Kick ass. All right, I love it. So far, 3, 4 in rectangular. In polar, this is known as R theta. Theta is 0.927.
Is theta always going to be in radical?
Not always, but that is a pretty big convention because do you guys remember the thing about theta? When can it not be degrees? For damn sure it can't be degrees. Does anyone remember?
With arc length?
Yeah, that's one specific example. I love it. Anytime I have a theta that is running around outside of a trig function, it has to be a physical measurement to make any damn sense. I could even, now watch, I could write sine of this, right? If I do sine of this, what is that trying to, not L, do you guys understand what this symbol means, right?
Yeah.
It doesn't even have to be a freaking number, and you can still do sine of it, right? In here just has to be any representation of a specific angle, anything. Because the sine will always come out to the same answer no matter what the hell this is. If it's out in the real world, it's outside, it's escaped, it has to be a measurement, a physical measurement. And the only way to represent an angle that does that is radians. So guess what? What, Jeff? When you get to a point in math, you start doing every damn thing in radians just to be safe. Because like I learned, if you have to do it one or the other, you start putting the calculator in the wrong mode and you're all screwed up. All right. All right, now to get R, all I have to do, in fact, does anyone know what R is? 3, 4.
5.
5. So just to check that, R squared equals 3 squared plus 4 squared. R squared equals 9 plus 16. R is 5. So the point 3, 4 in rectangular coordinates is the point 5.927. Now, I will say this. I wish that they had written this the other way. But too bad for me. Because how do I find that point? I don't go out a certain length and then I could walk out a certain length and then rotate. But it makes more sense to say, let me rotate and then start walking. But too bad for us. We weren't around back then, so too bad. So here, you guys do this one yourself. So rectangular point. Should I throw you? I'm going to throw you a negative. Let's see what you guys think. 2, -1. Oh, this might be too evil. Nah, screw it. Do it. Change that to polar. I like it. So evil. I'm sorry, I'm missing some chats. Well, just one chat. Good. Does the amount of circles we draw depend on how much we have to walk? Oh, okay. So somebody's got a really good question because I had drawn like that target thing earlier. It's getting a little ahead of ourselves, but if I draw some tick marks here, that's exactly like drawing the circles. So if I'm supposed to go out to 20, how do I do that? I've only got 4 tick marks. Oh, shit. But when I just call this 5, 10, 15, 20, then you with me? So in a polar graph, the circles are like tick marks, and I could call this 1, 2, or I can call this 5, 10, depending on what my R's kind of are, right? Okay, I like it. It's a very good question because I always forget to throw that in earlier. We do this later, but this is a good time to talk about that. All right. The R squared is the easy part of this, the R part. And of course, the theta part you have to be careful about. I don't know why I have to put you in parentheses. Anytime you use an inverse trig function, will the answer be the angle you want always? The answer will at least be a reference angle. All right, good. That's what Jason was about to say. What quadrant is this in?
Quadrant
4th.
Yeah, 4th quadrant. So now you know what your angle's got to be. Can your angle be negative? Yes. Can R be negative? Yeah. A negative R would just mean walk backwards. Right? If I turn and then walk backwards, that's another way to write a point. Weird. All right, so let's see. R is easy, right? Is that cool? 4 + 1 is 5, square root of 5, whoop-de-doo. What do you guys get for the inverse tangent of this?
-0.464.
I like it, which makes sense. Get used to what's 90 degrees? It's pi over 2, and pi over 2 is 1.57 basically. Does that make sense? So when I go to a deli and I get number 157, I geek out for a minute. And everybody's like, calm down, math boy. So the reason I bring that up is because that's obviously in the 4th quadrant because it's only 0.46 and this whole thing would be 1.57. Hopefully you guys are with me. So I know it's where it's supposed to be. So it's rad 5, comma, -0.464. I like it.
Does domain have an effect on this because it's like inverse tangent?
Yeah, if I would have said -2, 1 instead, wouldn't this have been the same equation? But my point would have been in what quadrant?
The second one?
Yes. So then this would have been a reference angle. I would have had to do pi minus this to get into this quadrant. Are you guys? I didn't really leave enough room to draw that well, but do you get the idea? Inverse trig sucks because we had to restrict the domain of the trig function to make it work in the first place. Therefore, inverse trig gives me sometimes reference angles, not the angle that I want. Damn you, inverse trig, which leads to the whole ass situation, right? I love it. If somebody hasn't been here for a while, like the ass situation, which is right, the triangle that has two possible answers, angle, side, side. Okay. All right. What'd you talk about in math tonight, sweetie? The ass situation. Okay. All right. Okay. Now, so let's talk about the other way around. So now we know if I give you rectangular, you can see how to convert to polar. That's nice. What about the other way around? So now I'm going to leave that up there. If I give you r theta, how do you determine x and y? Well, we know how to do this, don't we? Yeah, we do. Come on, we do. Y is r times what trig?
Sine of theta?
Yes. So x, of course, was going to be r.
Cosine of theta.
Kick ass. Is that cool? Oh, that kicks so much ass. So if I give you this going this way kicks, I continue to say that kicks a lot of ass. If I give you, what do you got, Jeff? If I give you -3 pi over 6, I love it. So you can do this without a calculator. To a point. What's the x piece and the y piece of the answer going to be? So this is r, this is theta. Yeah, there, Jeff. And this is yet another place where x likes cosine, y likes sine, saves your ass. And SOHCAHTOA continues to just be a joke on a shirt. My crusade against SOHCAHTOA. All right, you shouldn't need a calculator to at least do the next step, especially on one of these.
Would x be -3√3/2?
Yes, I like it because 30 degrees is closer to x, which is what this guy likes. And of course, that means the sine. Yeah, go ahead.
Yeah, y would be -3/2.
I like it. Now give me, I'll do this one. Whew. Now give me a decimal for that guy. I think it's like -2.58.
0.598.
I'm sorry. I'll just quit, you know.
Shame. For
I
shame.
know. I know already. I'm going to walk down. Somebody's going to beat something behind me. I'll be all naked. Shame. Sorry. That's for the Game of Thrones fans out there.
You need the
You've
bell.
never watched Thrones. Watch the first 6 1/3 seasons, maybe. I don't know how you guys feel. Maybe the first 7. The 8th season does not exist, except I don't mind the one part about the Night King. I don't mind that part. Sorry. Real quick, why does this make sense? What does this mean? Turn by how much? So I always start looking this way, which makes sense because that's 0 degrees, right? Or 0 radians even. So turn by pi over 6, but then I go where?
Backwards 3.
Back 3, and which is exactly where negative 2.598, negative 1.5 would be. Yes?
Yes.
Yes. Okay, so it's really nice to see it match with the concept. It's kind of nice. Now, here's the next level of this. So let me put up here what else we've learned. So now we've got rectangular to polar, and now we got polar to rectangular, which is really, really kick-ass. Here's what my personal favorite thing with this stuff, besides the cool-ass graphs you can make. I will put that in there. My personal favorite thing with this is working with equations and translating equations from polar to rectangular and vice versa. So for example, let's start with a nice one. What do you got, Jeff? I wish I knew. There we go. There, look, something's happening. I'm writing something. There it is. Look at that. Okay, now. Oh, what was that?
Oh, sorry, my computer's glitching.
All right. It'll be okay. I use that joke with my boss, just goes over her head. Oh, okay, I understand. So this is obviously trying to go from polar to rectangular. Do you guys now, of course, we don't know this shit yet too well, but if I saw an r cosine theta, what could I put there? X. Do you see r cosine theta? I see a cosine theta all by itself. It needs an r. So how do I accomplish that? How do I give it an r? Give me an r.
Is it r squared equals 7?
Yeah, you multiply both sides by r. Isn't that beautiful? And then r squared is something we know. And r cosine theta is something we know. So what do I put here?
X squared plus y squared.
Of course, what do I put here?
X.
And then just to go a little bit further, why did I have to pick 7? That's too damn bad, Jeff. Let's see if you can do it in your head anyway. I'm going to complete the square here. We might as well do this together. What is that the equation of? Anybody? Nobody?
Is it a parabola? Quadratic?
Because they're both squared. They're both squared. They both have the same coefficient.
A circle?
Circle. Kick ass. So look at what this says. What does this original equation say? R equals 7 times cosine of negative. Now that seems like R is not a constant, right? Like R equals 2 would be an absolutely silly little equation. That would just be a circle of radius 2, right? X, not radius 2, radius, it would actually, well, yes, you're right, Jeff. It would be radius 2. Okay, you got it. Here, I don't know why I picked 7. I was so evil to myself. But I can cut it in half and then square that. Add that same thing to both sides. Stay with me, stay with me, stay with me. And then I got this. So it's a circle that is offset. Can somebody tell me like where the center of this thing would be?
Would it be 7/2?
7/2, comma, the center is a point.
7/2, comma 0.
Yes. Because it's been shifted 7/2, but shifted this way, none. So it'd be 7/2, 0. There we go. Look at that scale. And what's the radius?
49/4.
No, it's the square root of that.
Oh wait, it's 7/2.
Yeah, so see how it would go exactly to here? And then it would go to 7, and then it would look like this. Wow, that's pretty good for me. Now. So. If I had if my equation was r equals 3 cosine theta, what do you think you could say about it? What would be true about it? What do you think? What would be different about 3 cosine theta versus 7 cosine theta?
The radius would be 1/2
Yeah, because it would go out to
or 1.5.
3 instead of 7, but it would still be over here, right? So what do you think about this? Well, what about r equals 3 sine theta? If r equals something cosine is on the x-axis, r equals something sine will probably be on the
Y-axis.
y-axis. Cool. All right, keep that in mind. Keep that in mind. I want to show you some shit on the graphing calculator. That's what that thing is. Stay with me now. I'm a little concerned, just a little bit, that I have less than 50% attendance. This is bad. All right. Let me open up my calculator. If you have your calculators, get them ready. All right, come on, buddy. There you are. Are you there? You're not there yet. Where are you? There it is. Okay. All right, so let me make sure I am in radians. Sweet. Now watch this. We're all used to when you hit the y equals, you get this, right? Now watch. If I go to mode, do you see where it says function? Do you see something else that we understand now? Polar. So if I change it to polar, so again, how did I get there? Mode, go down to function and make it polar. Now if you hit y equals, look what you get. So let's put that equation in that we just did. 7 cosine theta. Now this is going to be a little weird. Let's see what happens if I just hit graph. I don't know what the window's set to. Oh yeah, I got all kinds of weird shit. Give me a minute. I've got statistics going on. Let me turn statistics off. All right, let's try this. Hit zoom. Let's hit zoom trig. Zoom number 7. All right, that made it look like Stewie laying down. Oh well. Look at me, fat man. I'm a graph. All right. But it's basically where we said it should be, right? Let me hit zoom. Let's hit zoom standard. Now it looks the other way. I love it. All right. Why does it not look like a circle? Because the dimensions of the window are not the same, right? The tick marks here are further apart than they are there. Do you guys see that? All right. Are you guys at all with me? So what I want you to start doing now, watch this shit. Look what I'm going to do. So let me make this sign, and then it does exactly what we said it should. Now it's a circle that's centered on the y-axis, right? So what do you guys think about, what if I do 7 sine theta plus 7 cosine theta? Anybody have a guess for what that's going to be?
It'll be in the first quadrant.
Yes, centered in the first quadrant. I like it. And the radius is big enough to get it out there, but doesn't that make sense? And now watch. Then you can start doing some cool shit. I mean, so one level of this obviously is learning the specifics about how to translate from rectangular to polar, learning how to plot the polar points, all that stuff. The other level of this is try some shit and see what happens, right? This is part of what having a calculator is all about, believe it or not, is playing around. So what if I put in one of them a 2, but I don't put the other one as a 2? So now they're not the same kind of angle. Look at that shit. It did not take much to make this guy go a little insane. Isn't that cool? And now you start to see how not too many, well, to be honest, it gets a little freaky. But you can tell how this is going to make a butterfly if I get the equation right. And so obviously, I don't know, are you guys at all with me? I don't know if any of you are going to get interested enough to try to, what if you put a 3 in here? See, I can't even stop, and I know what's going to happen with some of this shit. Look at that. Look at that. That's crazy. It's crazy. Look at that little tiny little leaf in there. Nobody's speaking up. I'm guessing, are all of you getting the same images, or are not all of you able to do this with me? What's happening out there? Because I'm almost certain somebody's going to forget to make it radiance. I'm almost certain somebody's window's not going to be set the same as mine. What do you guys notice about the window? What are my angles going from to? See, theta min starts at 0 and theta max goes to 2 pi. Do you guys see that? Which makes sense for most things, but not all things. And my theta step is a pretty good little step size to get good resolution. Okay, maybe. But what if I were to make this, instead of 2, let me make this 0.2. Then I haven't gone far enough. Do you see what I'm saying? Because now I've changed the period of it. It takes longer than 0 to 2 pi to get all the way through its cycles. Does that make any sense? So that's why I have to know how to change this. Maybe I want to make this, well, if it's 0.2, I'm going to want to make it, let me see. All right. I have no idea. If the few of you that are actually logged in, if you're actually there, can somebody tell me what the period of this function will be? Who can put that together for me?
Would it be 4 pi? Oh, sorry, not 4 pi.
You got the right idea, I think. 2 pi divided by 0.2, right?
10 pi?
Which is
10 pi.
10 pi, exactly. So let me see where, there we go. Not there, window. All right. So now I want to make this 10 pi then, so it has a chance to get through its entire cycle. So now let's see what it does. Look at that shit. Sorry. I am sort of just playing around, to be really honest. I'm not necessarily making this happen on purpose. I sort of have an idea, obviously, what's going to happen. But when I made this 0.2, I wasn't exactly sure what was going to happen. But at least I knew how to let it go through its entire cycle, because I know about period. And that's why the standard default is 0 to 2 pi, which makes sense. But you might have to change that if you get some freaky shit happening to your period, right? Things
One
changing.
observation I have is you
Yes.
cannot use X in place of theta. You have to find theta on your calculator.
Oh, now look, no, I keep using this button. This is my all-purpose variable button. So you just always go to here. And each of these variables corresponds to the different modes.
Ah, so it selects it automatically.
Yes, exactly.
Awesome. Thank you.
Very good. I'm glad you said that. I'm sorry if other people are taking long. Yeah, the other modes we're going to learn. Parametric is the next thing we talk about after polar. And sequential is chapter 13. All right. Enough. Let me see, how much time do I have left? Not much. Oh, let's do this. Let me come back to the board. Let's do like maybe 2 more problems, then we'll call it a night. So hopefully I've inspired at least a person or two just to play around with shit, just see what happens. And then later you can try to connect it to the stuff we learned. Why what happened, right? So what if, yeah, let's do 2 more. I like it. Let's do 2 more problems. What if I give you, yeah, let's do that. I like that. Let's do, yeah, sure. I like this. This will be nice and freaky. And here my instructions would be convert this to rectangular equation. Now, what part of this do I not have any direct work with that I can do? I sort of can, to be honest. Let's see what you guys. What's r squared?
X squared plus y squared.
Yeah. What's cotangent theta? There's two ways you can handle that.
You can make it 1 over tangent. as
Yeah,
well.
yeah, you can do that all day long. Divide both sides. I'm sorry, you can make it 1 over 10 and then multiply both sides. That's what I'm trying to get to. Is that cool? That's 1 over tangent, so you can multiply both sides by tangent. And then what's tangent theta?
Y over x.
Y over x. I love it. Now, of course, you could have just put x over y here. Does that make sense? If tangent theta is y over x, then cotangent theta is x over y. But you get to the same place. And then if you multiply by x, now that is a funky ass equation. Can you easily solve that for y? No. Now watch this. So now I'm really curious what this equation looks like. Can I solve this for r? Yes, right? Because I really want you guys to get this. Can I input this into my graphing calculator somehow? No.
No.
Because in order to do it, I have to solve for y. To be 100% honest, I could solve this for y, but it's not going to be anything pretty. Would I rather solve this for r?
Yes.
Yes, because that would be r squared equals tangent theta. So r equals plus or minus square root of tangent theta, right? You guys semi with me? So if I graph this, it is the same as the graph of this. Because this is getting the same points this does, just using polar coordinates instead of rectangular coordinates, right? So polar coordinates obviously work best with functions that are circular somehow in nature, or periodic in nature for sure, right? So now I'm really curious, what the shit would this look like if I graphed it? It more than likely will not be a function, meaning it'll come back on itself in the XY sense, right? So let's see. Let's go back to the calculator now. I wasn't really planning on this, but now I want to see what this is. Get over there. All right, let me share this. Bam. Let's try to put this bad boy. Now, I got to be careful. If I want to put this in here, I'm going to have to put it in here in two pieces, right? Got in a positive one and a negative one. So let me, I've already forgot what it was. Square root of tangent, is that what it is? Square root of tangent, not inverse tangent, Jeff. And negative square root of tangent theta. And let me change my, let me just make this go back to 2 pi. I really don't have to because it should be quick anyway. And let's see what happens if I just hit graph. Oh, look at that weird shit. What is going on there? Oh, okay, that's right. Duh, forgot what I was doing. That is so funkadelic, dude. Look at that shit. On the one hand, it's kind of disappointing. On the other hand, it's funky. No? Let me get your like. Yeah, it's interesting, Jeff. Thanks, man. All right. One last one, and then we're done. That's what I promised. All right, this one's not going to be too crazy. So your thought process is sort of the same as the last time. We didn't have anything directly related to cotangent, so I had to think in terms of what I know. Same thing here. So how am I going to rewrite this?
Is it r squared equals r over cosine?
So here's the problem with that. I need r times cosine, and that would give me r divided by cosine. This doesn't relate to anything. But if you say secant is 1 over cosine, can you get these guys together like this? Yeah, right? When you just multiply that up? So when you have to translate equations between polar and rectangular, you're trying to make any of this shit show up. You're trying to make that happen. And sometimes there will be multiple ways to do it. This is a very classic one. This is neat. This equation uses trig. What does this look like? What does that look like if I graph it? Yeah, vertical line. So r equals secant theta makes a vertical line. I have no idea if you guys remember the animation I showed you. I think I got a link. I can't remember now. And secant was just that straight up and down line. So it's connected. Yeah. It's neat. So r equals cosecant would be the equivalent for a horizontal line, right? I like it. It's really some cool shit we're getting into. When we get to the real technical plotting points for graphing something by hand, I think I'm gonna, well, we have to make it through that. We have to make it through that. But it's so cool when you get enough points plotted out and you start to see what shape it's taking. It is kind of cool to do that. All right. So the next thing I want to do tomorrow is focus on plotting points. So you need to get polar graphs printed out for yourself so you can participate easier. All right. Otherwise, I think that's enough for tonight. Let me know if you need to hang out. Otherwise, thanks for coming. And I got to reach out and see what is happening to everybody else.
Bye.
Thank
Thank
you.
you.
Thank you.
You did mention that there's going to be a practice quiz out, right?
I gave a choice, and nobody participated in the choice making. So it's an open question. The last thing I said was, if somebody emails me and says, hey, you were gonna make a practice quiz, maybe, we'll see what I do.
Okay, thank you.
Question, when is the next quiz?
So it was supposed to be tomorrow, but I made it Monday on 9/1 through 9/4. Did I make it Monday, or was it
Yeah, Monday.
Monday? Okay, thank you for being
Okay,
honest.
good. That gives
I
me
got
enough
that
time
somewhere.
to review. Thank you.
You're welcome.
I have a question.
Yep.
So you kind of already talked about it during class, but I can't like finish the problem. I'm stuck still. It's
Which one?
9.336.
All right, let's see. There we go. 36. Oh yeah. Okay. Let me see. So you can help me get caught back up to where I got you, right? Because we figured out that cotangent. Yes.
So for the homework, are you gonna like change the due dates, or are you just gonna keep the same?
Yeah, you could do me a big favor and everybody else and shoot me an email and say, can you look at the due dates, Jeff? I think I already changed some of the chapter 9 due dates, but if you see that I didn't, you can always just shoot me an email.
Okay, thank you.
Sure. Let me see. I can't remember what this came out to be.
1 minus tangent squared x over tangent x. 2
All right, hold
tangent.
on. 1 minus tangent squared.
Yeah, over 2 tangent x.
Oh yeah, okay, that sounds familiar. And then of course you bring the 2 up. So you got 2 cotangent 2x equals 1 minus tangent squared x over tangent x. What's 1 over tangent x?
Oh, okay. I don't know why I crossed the 2's. You said the 2's cross, so
Yeah, because you multiply both sides by 2. And see, now I've got this, don't I?
oh, okay. So then you have your cotangent x.
So
minus-
basically I came from this side, I made that side look like this, and now I can make this look like the other side.
but
So
then
that
it's
can,
still minus a tangent squared x.
no, it isn't. What's being divided by tangent?
Oh, you're dividing both sides by tangent. Okay. Okay,
Yeah.
makes sense.
Good.
Okay, thank you.
You're welcome. All right. How long myself now? Let me see. I don't know. Would you look at that? Got the whole room to myself. I'm still recording. Hey, everybody. Thanks for making it to the end of the video. Like and subscribe. Yeah. All right. Bye. What button do you push? Oh, yeah.